The first members in the group are less reactive than the lower. Reactivity increases down the group. Ending. The easier a metallic atom loses its outermost electron, the more reactive it is. As we said, potassium can easily lose its outermost electron, it is the most reactive. Lithium can hardly lose its outermost electron, that is why it is the least reactive. Now, I'm going to reaction of group 1 elements with water. But I know, yes, Daphne?
Teacher, just wanted to clarify something. So you say that the reactivity series, the reactivity increases down the group. Is it the same as saying the atomic size increases down the group, or is there different things?
Oh, maybe let me answer your question, then we can continue. Atomic size increases down the group. Yes. If you look at lithium, I'm going to use an imagination with sizes. Just look at the sizes. Lithium has 2 energy levels. It is smaller. Sodium has 3 energy levels. It is slightly bigger. Then potassium has 4, let me see, 1, 2, 3, 4. 4 energy levels, meaning it is the biggest. So that means that potassium is the biggest size, that is the atomic size. Then lithium has the smallest atomic size. Yes, you can also say atomic size increases down the group. They are not the same, but they are all correct. But atomic size you've seen, which is more like the size of an atom. Then reactivity goes to how these metals react when they are with other atoms or other elements or other substances. Okay, now it's my turn to ask questions. You're welcome. It's my turn to ask questions, and then we continue because we studied this. Now, reactions with cold water. Can someone remind us how sodium reacts with cold water? We're going to look at sodium and potassium. Let's start with sodium. Those who remember how sodium reacts with water, let's put up our hands and say out or speak what you remember. Faith, you can start. Tell us what you remember about sodium reacting with water. Faith first.
When you are looking at how sodium reacts with water, we say that the gray sodium solid will melt into a small silvery ball, and then it gradually becomes smaller as it's giving off a hissing sound. Then when it's getting finished, it explodes. Then the residual solution left feels soapy and slippery. And it's alkaline. The solution produced is alkaline.
Okay, girls, thank you very much. Thank you very much. Do you have anyone who is planning to add something on sodium? If you have something to add on sodium, put up your hand. I see Cynthia, I see Angel. If you're adding something on sodium, yes, speak. Cynthia, you can unmute yourself if you have something to add.
It gives off a colorless gas that gives off a pop sound when a burning splint is lowered into the gas jar of hydrogen.
Okay, that gas is produced, but we always listen to a hissing sound. I'm going to show you this experiment in a few minutes. Then we can confirm if our observations are correct. Daphne, do you have something to add on sodium?
Yes.
And
Sodium.
Grace? Yes, you add.
Sodium readily reacts with air and water, so it's kept in oil.
Kept under oil. Thank you. Lastly, Grace.
Sodium explodes to give a yellow flame.
Yellow flame. Sometimes it explodes. That is sometimes. Sometimes it does not. Other times it explodes to produce a yellow flame. Shona, do you have lastly, do you have something to say about sodium?
That it reacts with water to form a hydroxide.
What is the name of the hydroxide?
Sodium hydroxide.
Perfect, thank you. But when they say state observations, you just talk about things that you can see, things that you can hear, and things that you can feel. So, like when you say it produces sodium hydroxide, that is not an observation, but later we're going to look at how we state it as an observation. Okay, let's talk about observation. Lastly, girls, another question. Observations made when potassium. Girls, let's unmute ourselves. Okay. How potassium reacts with cold water. Do you remember something about potassium reacting with cold water? Let's talk about potassium reacting with cold water.
The banana crisp you're supposed to share. You too, because I shared with Gina. Supposed to share with you.
Okay. Kosinje, then layer in that order. You've not given us points, so you can start.
Babe, can you babe?
When potassium reacts with water, it produces a lilac flame.
Yes. Okay, next person. Let me see. Grace, continue.
Potassium reacts much faster than sodium.
Perfect. Kajimu, Jovia.
Completely dissolves to give off a colorless solution that turns red litmus paper blue.
Okay. The two hands that are up, can you finish your point? Unmute yourselves and speak. I'm going to share with you a video as these two people are giving out their points. Of video showing the reaction of sodium and potassium with cold water. Yes, lastly, I see, do I see any hand up? Yes, there's one person whose hand is up. Unmute yourself and
Potassium that's around the water, about the water.
thank you. Guys, let me share with you a video briefly. It shows how those react with cold water. Okay, let's listen in, then after I'll ask a few questions and continue with our lesson. You can tell me when you.
Mr. Arjuna, if the video is playing, we're not hearing. Maybe
Has
you
started.
Has it started?
These are the three metals that are in group 1 that we are
Okay, it's fine, we can hear.
Lithium, sodium, and potassium. You can maybe see from the hazard symbols on the container that actually they're quite dangerous chemicals. They're very reactive. Look at how they're stored. They're stored different than other metals. So they're inside a plastic container and then inside a jar. Now, I'm not sure if you can see in the video, but inside the jar, there's new. If you're in year 8, you maybe haven't seen this before. So these are the three metals that are in group 1 that we are allowed in school. So we've got lithium, sodium, and potassium. You can maybe see from the hazard symbols on the container that actually they're quite dangerous chemicals. They're very reactive. Look at how they're stored. They're stored different than other metals. So they're inside a plastic container and then inside a jar. Now, I'm not sure if you can see in the video, but inside the jar there's a liquid, and with lithium the metal's floating on top of the liquid. The liquid in here is oil, and it's to stop lithium reacting with any moisture or any oxygen in the air. So whenever we want to take a sample of the metal, we need to fish it out of the oil, which is not very easy. Okay, there's a wee tiny bit. And we're going to use a paper towel, and we're going to make sure all the oil is wiped off, and then put the lid back on. So we've got a little tiny bit of metal. It's not what you would expect for a normal metal. So if you ask me to describe a normal metal, we might not describe what lithium looks like, or sodium, or potassium. So you'll see it's actually quite dull. It's very easy to cut, but watch when I cut it to see when I cut it, it's actually quite shiny inside, but then it quickly goes dull. So easy to cut, and then it's shiny, and then it goes dull once it reacts with the oxygen in the air. Okay, most metals don't do that. Most metals you can't cut with a knife, whereas group 1 metals you can. So I'm just going to cut this up into another piece and then show you these pieces reacting with the water. So put the lid on that one. Now lithium is at the top of group 1. It's in group 1 period 2. Remember if you've done that. So once it goes into the water, it floats in the water and it immediately starts to fizz. So our observations for this reaction is that the lithium floats, it fizzes. You maybe hear the fizzing and the bubbles. It moves around on the surface of the water and it just disappears. The metal's getting smaller. The gas that it's producing is hydrogen. So if you think back to your work where we were testing our gases, the test for hydrogen gas is it burns with squeaky pop. I'm just going to try and prove that this is hydrogen, so listen to the pop. Okay, so that proves to us it's hydrogen. Now, that isn't an observation for this reaction. The observation is just that it's fizzing. So remember, an observation is what you see, what you hear, and what you feel. So I'll go over those observations again, because you maybe need to write those in your booklet. So the lithium floats on the water, it fizzes, it moves around the surface, and then the lithium gets smaller. Okay, so those were the observations when lithium reacted with water. The equation is, so lithium plus water produces lithium hydroxide plus hydrogen, and the symbol equation is written underneath. Now at the end, once I finish reacting all these metals, I'll show you what it means to have a hydroxide produced. So these are called our alkali metals because when they react with water, they produce an alkali. So lithium hydroxide is an alkali, but we'll also do it whenever we have sodium and potassium. So now I'm going to show you what happens when we react sodium. Again, it's stored in the same type of container. And inside the plastic container is our bottle. And we've got oil in our bottle again, and the sodium this time is at the bottom of the oil. Wonder if you can see it in the video or not. So again, we're going to use the tweezers to fish out a bit of sodium. Now actually, watch what the difference is between the lithium and sodium, because what I can do with the sodium is I can stick the tweezers in it. I don't even need to hold it with the tweezers, see they're not hold it with tweezers, I was able just to stick it in it. So most metals aren't that soft. I'll probably lift it out more than one bit here. So remember, I'm drying off all the oil. It's one of our safety precautions and our risk assessment that we have to dry off all the oil. So maybe at the top of the page you have to fill in your risk assessment for this. So this is one of the bits about our risk assessment. We don't want to have oil on the metal still when we put it into the water, because we know that oil and water don't mix. So there's a little bit with the oil wiped off it. I'm going to get another wee tiny bit. So sodium is really soft. I'll put that bit back in the bottle. Try to dry a bit with the paper towel. Make sure all that oil is off. Okay. Now again, it can be cut with a knife. So it's a dull color at the minute. And watch what happens. It goes shiny. It goes dull a lot quicker than the lithium did. So it reacts with the oxygen, but it reacts faster with the oxygen than the lithium did. Okay. And same with this one. Really easy to cut. So let's have a look at what happens when we put sodium into water. So again, we're writing down our observations in your book. So I want you particularly to pay attention to the shape of it is at the start, once it hits the water. So have a look at the shape it's turned into. So one of the observations is that sodium melts into a ball, it fizzes, and again it floats on the surface. Now, sodium has a particular movement around the surface of the water, and we'll see if we can get it with this next one. So again, look at the shape. I'm going to try and drop it into the middle now. So it melts into a ball, and the movement is described as it zigzags across the surface. So it goes in straight lines, hit the side of the bowl, and then it zigzags across. Again, the gas that's being produced, we can just confirm it's hydrogen by seeing if it burns the squeaky pop. Listen to the pop. Don't know if you heard that very well. We'll try it with the next step whenever it's a bit bigger and see. Okay, and so our observations, it fizzes, the sodium gets smaller, it zigzags across the surface of the water, and it floats. Those are observations. Okay, and then the last bit. So see the way it's just melts into a circle. It didn't start off as a circle. Pretty cool. Let's see if we test it, see if we can confirm it's hydrogen. There you go, it burns with the squeaky pop. Now it's staying on fire because that's a hydrogen that's burning. So that's not part of the observation of the reaction. So the observation of our reaction again is the fizzing. This time it's maybe, you can maybe see the water's getting a wee bit cloudy underneath. Rather than doing that with this lithium. But that is the sodium. Okay, so our reaction then, our equation for sodium is the same as lithium. We've got sodium plus water goes to sodium hydroxide plus hydrogen. And there's a symbol equation underneath as well. So remember, sodium hydroxide is an alkali as well. And then our last one I'm going to show you is potassium hydroxide. So again, we've got our hazard symbols on it to tell us that we have to be careful. Have a look at the difference between the storage. This one is more reactive. As you go down group 1, it gets more reactive. So again, we've got oil in the bottle. I'm not sure if you can see, there's some chunks of the potassium at the bottom. So what do you think? Do you think I'm going to be able to stab this with the tongs the way I did the last one? And if I bring it out, get my paper towel ready. So you see, I did just stab it with one bit of the tongue. So again, it's very soft. It's not, these group 1 metals are not like normal metals. They don't have the normal properties. So our properties of our normal metals would be, they'd be shiny, they'd be hard, they'd have high melting points. None of those are true. Well, actually, they are shiny when they're cut, but then they react with the oxygen. So let's see with the potassium. Again, it's just very dull at the start. So I'm going to watch how easy it is to cut, and then watch how quickly this goes dull compared to the other two. Probably dull already, is it? So that's just so I'll do 3 bits of this one as well. So another part of our risk assessment is that there's a limit to the size of piece. So I'm only using very small pieces of the metal. So if I just go over the points of our risk assessment, we're wiping off the oil. We're making sure that the bottles are all closed and out of the way before I put the metal into the water. We're using a very small piece, and when I put it in the water, I'm standing back. So watch with the lithium, it's a bit different than the other two because we're getting further down the route, so it's more reactive. So watch what happens when we put lithium in. Pretty cool, eh? So our observations for lithium, it caught fire, didn't it? Burns with a lilac flame. So when we do our flame tests, We know that the flame test for potassium is a lilac flame. It fizzles. It fizzes. You can hear the fizzing. It sparks. When we see sparks, it floats on the surface, and we can definitely see the liquid going cloudy this time. And our last piece of potassium. Ooh, how's it going? And then our equation for potassium is potassium plus water equals potassium hydroxide plus hydrogen. So again, those equations are very similar, simple equations there as well. And the reason that they're called alkali metals is that they produce this hydroxide. So the lithium hydroxide, the sodium hydroxide, and potassium hydroxide. So if you remember back to our pH scale and what acids and alkalis are, school bell going in the background. So when we add universal indicator to it, we can see that the water, which started off as neutral, has turned to a dark blue colour, which has sodium hydroxide, a mixture of sodium hydroxide, potassium hydroxide, and lithium hydroxide. So it's produced an alkali when the metals have reacted with water. So the last bit I want to show you is just the electronic structure of the three metals. So they're all in group 1. They all have 1 electron in the outer shell, but as you go down the group, they get more reactive. I want you to think back to what we were talking about when we did electronic structure, and just have a think and see whether you can describe why they get more reactive in terms of that outer electron. Okay?
Okay. Hope we are there. Any questions? Definitely, and mute yourself and say something.
Teacher, I have a problem. Like, how do you determine like that first number in front? Like when you say sodium, like when they say 2Na, like how do you determine the first number? Yeah, that's my question. Let me show you now.
Repeat your question, Daphne.
I was asking that how do you know like the first number to write like on a metal? Like how do you know? Like I'm seeing somewhere they can write 4, then other places 2. So how do you know what to write?
I believe I'm trying to think that I've understood your question. Is it when you write in the electronic configuration, or because when you write in the electronic configuration?
Asking when writing them.
Balancing equation.
Yes, balancing the equation.
Oh, no, we're going to learn equations. We are going to talk about equations later. Okay, Jovia, then we continue. No, Paula, then Jovia, then continue. Paula, then Jovia.
Excuse me, sir. I had a question. When she was throwing these, cutting up the sodium and the potassium, the potassium, I noticed that she wasn't touching it with her hands. When you touch it with your hands, is there like a reaction, like will it hurt you?
Yes, they are corrosive to our skins, so it is not advisable to touch them. That is why, even when they are keeping them, you realize that they keep them under oil, meaning they still don't need them to be exposed to the environment. So the way we don't want them to be exposed to the environment is the same way we don't want them to be exposed to our skin. They are very
Thank you, sir. Sir, also, can you please upload this video to Google Classroom, because like some of the time it was freezing, so I didn't catch all the information.
Okay, it is fine. I can forward a link. I'll share a link, then you can always get it. Yes, Jovia and Karen.
Teacher, I was asking, like, since It's like these group one elements like form basic oxides. Do they also like react with acids to form water and a salt?
Yes. We're going to do that when we start studying reactions with acids and bases. You realize that all bases, those are hydroxides and oxides, react with acids to always form a salt and water. But that is the next topic. Next. The next person.
Excuse me, teacher. I have a question about
There's some
excuse me, teacher.
Yes.
I have a question. It's not directly linked to the video, but how many energy levels are there? Like after 288, how many are there after that? How is there like an N or like how many are there?
Okay, thank you very much. When you look at the periodic table, there are very many elements that are there. The only thing that maybe you need to know, but you don't need it right now, is that when you reach at 88, rather 83, reach an element in position 83, those elements above 83, they are radioactive. They always, have you ever heard of the word radioactive? They always break down continuously, emitting rays. But there are so many that when you go online and you download the periodic table, you realize that there are over 100. Just that for all info, we only need us to concentrate on the first 20 elements. So for now, you just focus on the first 20 elements, but you can download the periodic table and see that there are so many, but don't focus on them because you study the map when you continue in chemistry. But there are many. Lastly, any other person with a question, then we'll continue. We have a few minutes. Okay, so let's continue. Now, you've now realized that metals react with cold water, group 1 metals, that is potassium, sodium, and lithium. But in O level, we don't focus on lithium a lot. That's why in your notes, you don't have lithium written there. But of course, you've seen how it reacts with cold water. But the main point that I need us to take home today is that group 1 metals react with cold water, forming metal hydroxide and hydrogen gas. We studied observations last time, so I believe you can go back and read about it. Next property. They all burn in air to form basic oxide. So I have a question, girls. We studied oxygen in senior 1. Can you remind us how sodium reacts with oxygen? Those who can remember how sodium reacts with oxygen, we put up our hands and we talk about it. Okay, I see 2 hands up. Let us start with, let's see. Martha, can you help me there? I'm not seeing names for people whose hands are up.
Let's have Paula. Paula, you can unmute.
I forgot my hand.
Okay, Berito.
The silvery white metal burns with a bright yellow flame to form a yellow solid called sodium peroxide. Or if there is little oxygen, it's going to burn and form sodium oxide.
Okay, thank you very much. I think we can see what she has told us on our screen. Sodium burns in air with a yellow flame, forming a white solid of sodium oxide. In excess oxygen, it burns to form sodium peroxide, which is a yellow solid. Now, number 2, can someone tell us how potassium burns in oxygen? By show of hands. Angel.
Teacher, potassium also burns in oxygen with a lilac flame and forms potassium peroxide. Yes, a white solid of potassium peroxide.
Yes, perfect. I see many hands up, and we have someone who is planning to add something on sodium or potassium.
Yes.
And unmute yourself and say your points. Yes.
Potassium burns with a lilac flame to produce a white solid of potassium oxide.
White solid of potassium oxide. That happens when oxygen is. Thank you very much. Do you have any other person who's adding something on reaction to potassium?
Excuse me, teacher.
Yes.
Does potassium also produce a peroxide or just sodium?
Yes. Even potassium can produce a peroxide.
Okay, thank you.
You're welcome. So, do you have any question or questions? I have a small video to show you about these colors. Do you have any other question or questions? If I can show you. Okay.
Potassium react violently with water.
Okay.
And flammable hydrogen is formed. All of the used compounds can cause severe chemical burns on the skin and eyes. Sodium peroxide and potassium superoxide are oxidizers. I don't take any responsibility for damage done to persons or property. I recently remembered an old video uploaded by the user Nick Moore in which lithium was ignited in air, so I was wondering if sodium might react similar. Usually it is shown that it reacts with water and the hydrogen that is formed burns with a flame that has the typical yellow color. So I put a piece of sodium on a metal plate and heated it with a Bunsen burner until the reaction took place. Usually it is shown that it reacts with water and the hydrogen that is formed burns with a flame that has the typical yellow color. So I put a piece of sodium on a metal plate and heated it with a Bunsen burner until the reaction took place. What followed was for sure one of the most beautiful reactions I had seen. The sodium has reacted with the oxygen from the air to form a mixture of white sodium oxide and yellow sodium peroxide. Sodium peroxide is a strong oxidizer but is only present in small amounts due to the low concentration of oxygen in the air.
Okay, girls, we can take it from there. That we can finish our reactions. A few items that I need us to note down. Let's go back to our notes. Okay, so let's move. Number 5, say that all group 1 elements can form basic oxide. And now we know that basic oxides are oxides of metals which, when dissolved in water, form alkaline solutions. In the previous video, we saw that alkaline solutions can inversely indicate a group. So let's start with lithium. As we said, we don't focus on lithium a lot in O level, but let's still talk about it. Now, lithium also burns with a red flame. There is some sound in the background. Girls, let's check our videos and audios. Okay, so we say for lithium, it burns with a red flame, forming lithium oxide. So lithium oxide, since it is also an oxide from a metal, it is also a basic oxide. For now, let's focus on getting the word equations. We're going to learn how to write very well forming equations and how to balance them. Now, the only challenge or the only difference is for lithium, it also likes nitrogen. So when lithium is burning in the atmosphere, when lithium is being burnt, or maybe when it's being heated on, let's say, on top of a Bunsen flame, it also combines with nitrogen. So instead of forming lithium oxide first, it also forms lithium nitride. When lithium combines with nitrogen and lithium, they combine to form lithium nitride. You see the difference. Oxygen, we form oxide, IDE at the end. Nitrogen, we form nitride, IDE at the end. So that is something that you need to know. So that is how special lithium is. So for lithium, we don't have cases of saying it reacts with excess oxygen or limited oxygen. No, it just reacts with oxygen, whether it is too much or little, to form lithium oxide, the white solid. Or when there is after reacting with oxygen or before, sometimes they react concurrently at the same time. Lithium also burns with air, picking out nitrogen from lithium nitride, which is also a white solid. Then lastly, these points you had shared with us, the video was showing us how sodium burns in oxygen. One of you had told us that. What you need to know is that sodium is a silvery gray solid. You need to know that. It's a silvery gray solid. It burns with a yellow flame. Some books say bright yellow flame. Make sure that you take that color. You always note that color. Form white solid of sodium oxide when oxygen is little. Many times when they just say reacting with air, air has only a smaller composition of oxygen. So air shows that the composition of oxygen is little, 21%. But when they say a gas jar of oxygen, that means oxygen is enough. But other times they just say excess oxygen. Good. So in that case, when we have excess oxygen, everything is the same. Sodium burns with a bright yellow flame or a yellow flame. But in this case, we don't form a white solid, we form a yellow solid of sodium peroxide. If you realize in our video, they formed both. We had something whitish and with yellow things, meaning some parts reacted with excess oxygen, those that could only access limited oxygen formed white solids. And lastly, for potassium, the same story. Potassium burns in air, form potassium oxide, lilac flame. But when there is enough oxygen, we form potassium peroxide. So in this case, I need you to go back to senior one, oxygen combustion. Revise these experiments, make sure that you get them well, so that by the time you continue moving, you're sure of what we are making. Since these oxides are alkali, from alkaline metals, form alkaline solutions. That's why we call them basic oxides. If you see what is put in your notes at this point, all these oxides form, they form bases. This one, this one, this one. That is why these oxides are called basic oxides. Do you have any questions or any questions from reactions of group 1 element with oxygen, or any related question, or a question related to that video? Let's summarize those questions. Jemima, Esther.
Teacher, what does AQ mean?
It means aqueous, dissolved in water. It means dissolved in water, aqueous. That's the full word. Or that is AQ in full, aqueous, which means dissolved in water.
Thank you, teacher.
Our group 1 elements reducing or like oxidizing agent.
Okay, thank you, Jovia, for that question. Later, I need us to, maybe you can just note it down, but you're going to study it with time. Elements that react by, let's start with oxygen. We say elements that react by gaining oxygen or losing oxygen. That's why I want us to start from. Oxidation is adding oxygen. Elements that react by adding oxygen are called oxidizing agents. Is it okay? Now, elements that react by donating electrons, because we say all metals react by donating electrons. They give away electrons. They are also called reducing. So it's the opposite. If oxidizing agents give away, they donate oxygen. Still, if we say they donate electrons, now that is opposite. They are reducing agents. Let me write them down. So you can note them down. Group 1 metals, elements react by donate by losing or donating electrons. Therefore, they Actually, our time is over, so let's summarize those questions and finish. So we've said we have those that donate. I need you to get it from donating oxygen, then opposite, gaining electrons, then gaining hydrogen. So the there are elements that donate oxygen, that gain electrons, that gain hydrogen. All these, how can I circle them? All these three are called oxidizing. Oxidizing, hope you're seeing them, oxidizing and oxidizing. But we say that metals, remember I said all metals ionize by losing electrons. They ionize by losing electrons. So those that lose electrons, those that gain electrons, we say they are oxidizing. Those that lose electrons are called reducing. Reducing agents. Okay, I hope I've answered your question.
Yes, Mr.
Because you know, by the all metals, group 1, 2, 3, they are all reduced. They all lose electrons. Okay, Mr. Bato, girls, that's the end of our lesson. Let's keep revising and yeah, enjoy your day.